Hello everyone, hope you're doing well. In this class we will continue what we've started with operations of matrices. Basically, as we said, we have the summation of matrices, which is immediately we take all the elements of the matrix A, we take each element from A and we add this element to the corresponding element from B. So basically it's a very easy operation, just we add these elements. In case of subtraction of these two matrices, we take the first element minus the second or the corresponding one. This is the summation of two matrices. While when we have the scalar multiplication, which means multiplication or taking a scalar, which is a number lambda multiplied by the matrix A, so we take each one of these or of this matrix and we multiply this number by this scalar, which is in this case lambda, and we will get a new matrix. The new matrix or the order of the new matrix is the same order of the old one. Okay, matrix multiplication. In this class we would talk about the multiplication of two matrices. Let's take this example. If we have the matrix A, which is M multiplied by B, and let's take another one, which is B. In this case, the order of the matrix B is P multiplied by N. So if we want to define A times B, or the multiplication of the matrix E by B, we will get, or we can define a new matrix, which is C, and the order of this matrix, which is C in this case, would be M multiplied by N. Why it's M multiplied by N? Because in this case, the common number between these two matrices is P. So we can define each one of these elements, the new elements of the matrix C by Cij, equals to the summations of the first element multiplied by the second element from the second matrix, and we do the summation over P. Let's take an example of this operations. Let's have A, which is 3 columns and 2 rows. So this means the order of this A is 2 multiplied by 3. And let's take another matrix, which is B, and the order or the dimension of this matrix is 3, which is 3 rows multiplied by 2 columns. So the answer, which is in this case C, would be a new matrix. So how to find the elements of this new matrix? Let's start by taking the element, which is C21. 2 represents the number of row and 1 represents the number of columns. So in this case C21, so we would go to the matrix A and we will take the second row, and we would go to the second matrix, which is B, and we will take the first column. So second row from A, first column from B. Let's do the multiplication. 0 multiplied by -1, 0 multiplied or times -1, and then we add 1 multiplied by 2 plus 4 multiplied by 5. So again, we take the second row, the first column, and we do the summation. 0 multiplied by -1 plus 1 times 2 plus 4 times 5. So if we do these calculation or this calculation, we will get C21, which is in this case 22. Now let's try to find the other elements. A, as we said, 2 rows, 3 columns. B equals to 3 rows, and 2 columns. C11. So in this case, the first row and the first column from B. Doing the multiplication, we will get this. 1 multiplied by -2 plus 2 multiplied by 2 plus 3 multiplied by 5. So the first row and the first column, we will get C11. Let's try to do C12. So the first row, which is this, and the second column, which is this. So 1 times 2, 2 times 3, and 3 times 0. Doing the calculation, we will get C12. Again, as we did C21. Second row, first column, second row, first column. Doing the calculation, we will get C21. Doing the same for C22, we will get second row with the second column, 0 times 2, 1 times 3, and 4 times 0. So we will get the new elements of the new matrix, which is the multiplication of A multiplied by the matrix B. So C, in this case, A multiplied by B, A multiplied or times B, we will get the new matrix, which is 2 by 2. So the order of this matrix is 2 by 2. Okay guys, let's take the special case of matrix multiplication. In this particular example, we have A, which is 1 times M. So A in this case is a vector starting from 1 until M. And let's take B as M multiplied by 1, which is another vector, but the difference is we have horizontal and vertical vectors. So if we want to do the multiplication of these two matrices, we can cross this M with this M because it's a common number. So the new matrix C, the new answer will be 1 by 1. And once we have this new matrix, which has the order 1 multiplied by 1, so we can say this is a scalar number or a number. So A multiplied by B, in this case, instead of having a matrix, we will have a scalar. This is A multiplied by B. Let's take the same example, but in this case, instead of having A multiplied by B, we will do B times A. So instead of having a new matrix 1 by 1, we would have a new matrix, and the order of this new matrix is M multiplied by M, or M times M. So BA in this case, having A multiplied B multiplied by A, we will get a new matrix. And the order of this new matrix, it's not 1 by 1 as in A times B, but in this case M times M. So we can take this note. In general, we cannot say A times B equals to B times A. It's not the same, but we have some cases, some special cases when we have AB equals to BA. But normally in general, no, it's not the same. Now let's have a look at the properties of these operations. So let's say we have A and B and C conformable matrices. This means that A and B and C, or the order of these matrices, we can add, subtract, and multiply them. The first one is, if we have A multiplied by the addition of B and C, so we can distribute this A over B and C. Again, if we have A plus B and the addition of A plus B, we can distribute this over C, so A equals to A times C plus B times C. Third one is, if we have the multiplication of three matrices, we can say A multiplied by BC, we can do the AB multiplied by C. And if we do some examples about this with numbers, we can prove that this property is very important when we have more than one or two matrices. In the previous slide, as we said, as we proved that A normally in general, we cannot say A times B is equals to B times A. And the most important note in this class is, if we have the multiplication of two matrices equals 0, this does not necessarily imply that one of these matrices A or B equals to 0. The last property, if we have A times B equals A times C, so still we cannot say that B is equals to C. So guys, the properties with numbers are totally different from matrices. So we have to pay attention especially to these three properties. Thank you so much for your attention. See you inshallah in the next class.